Hi everyone, so the first time I recorded this video, it recorded without any sound. I don't know what's going on with the audio. Hopefully I can get it figured out for future videos so I don't have to go back and redo it, but right now I'm just re-recording the audio on top of the video that I had already made. So before we get into the test review worksheet, I wanted to just give you some general tips and suggestions for studying for a test, and I wanted to share about a strategy that students of mine in the past have found very helpful in studying, and that is to create your own practice test on a blank sheet of notebook paper. You could even type it if you want. Find questions, find practice test questions. You can find them previously worked problems from our notes, our class notes. You can find problems in the textbook, ones that I've assigned for homework, or even some of the other ones that I didn't assign. The answers to the odd number problems are in the back of your textbook, and just find problems. You can use the test review as a good resource to get an idea of the variety of different types of problems that will be on the test, and you can find similar problems just with different numbers that kind of match what's in the test review. And once you've made your test, actually sit down and take your test. So do a full practice run, put your phone away, put your notes away, do everything like that. You can even kind of set a timer, give yourself a time limit similar to the time amount that you're going to have in class, and go through and take it. And then when you're finished, go ahead and grab a grading pen, go back through and actually grade your test. You can have each question be worth 1 point. You can actually calculate your score, write it at the top of your paper, and that's going to give you an idea of what score you may receive on the actual test. And you can really repeat that process multiple times if you need to. Okay, so let's get into the test review. So the first section here, this is going to be on the non-calculator portion of our test, which is Tuesday. So we're matching up equations. And so first I'm looking at the 3x squared and the 12x squared. So both of those have a vertex at 0, 0. And the 12 in front is going to make it very vertically stretched. It's going to be very skinny and narrow, so that's going to be this one over here. I don't know why it just keeps going up and down. Okay, so let's label that B. And then the other one with a vertex of 0, 0, it's not as vertically stretched, is this one down here, so let's do that as A. Okay, the next two are both negative. They're concave down, and there's a fraction in front, which means it's vertically compressed, so it's going to look a little wider. So the 1/10, that is going to make it wider than the 1/2. And the vertex is still at 0, 0, so that one down there, D, that's going to be the negative 1/10 in front, and then C in the lower right was the negative 1/2. Okay, the next one here, vertex is at negative 5, negative 6, and it's concave up. So let's see if we can find that one. That's going to be right down here, so we'll label that E. Okay, next equation down here has a vertex of positive 5, negative 6. So that's this first graph right there in the corner. Next one has a vertex of negative 3, negative 1, and it's concave up, so that's going to be this one. Next, this one is going to be concave down because of the negative in front. The vertex is positive 3, positive 1, so that's going to be this one. All right, finally, our last one is vertically stretched, the 2 in front, so it's a little narrower than the original, and it's shifted down 4 units, so that's going to be our last one. All right, so just doing some matching. Okay, next, this is also going to be on Tuesday's portion of the test. This time, our equation is in standard form, so we're going to find the x value of the vertex by doing negative b over 2a. So b is 2, a is 1. Negative b over 2a, so that ends up being negative 2 over 2, which is negative 1. That little formula, you want to memorize that. So that's the x value of our vertex. To find our y value, we'll go ahead and plug that x value into the equation, and we end up getting our y value as negative 4. The axis of symmetry x value is always the same as the x value of the vertex. Now it's very easy to get the y-intercept in standard form. The y-intercept is when x is equal to 0. So if you plug in 0 for x, you're just left with the number at the end, which is negative 3. So let's go ahead and sketch our graph. So we'll start by doing our vertex, negative 1, negative 4. Our y-intercept at negative 3, so it's the right-hand side of our parabola. We use the symmetry property to help us get the third point. Domain is all real numbers. This time our range is just y values greater than or equal to -4. You can also do the interval notation, which is a bracket around the -4, comma, infinity. Okay, now to get the vertex form, we need the vertex. So +1 squared minus 4, and the a value in front, okay, hold on. So the x value of our vertex is the opposite sign. The y value of our vertex is the same sign. All right, the a value in front, I know that it's +1 because it's the same a value in the standard form, so you don't actually have to solve for that one. It's very easy to just transfer that number down. Okay, next, this is also in standard form again, so let's start by thinking about finding the x value of our vertex. So this time our b value is -3, so -3. Our a value is -1, so it's going to be over 2 times -1. There's lots of negatives here, so be careful. Turns into +3 over -2, which is -1.5. So if we look at our answer choices, it looks like we can eliminate this one because the x value of the vertex is not -1.5. Also, our graph is going to be concave down because of the negative that's out in front. So we should also be able to eliminate this one because it's not concave down. Okay, so now between the two that are left, something that could differentiate between the two is the y-intercept. You could find the y value of the vertex. You could certainly do that. I'm going to look up at the equation to get the y-intercept. It's just going to be that -8, that number that's on the end. Okay, so we can eliminate that top one. That looks like that actually has a y-intercept of 8, so we can narrow our answer down to this. Okay, next, so again, this next question is on the non-calculator part of the test on Tuesday. X value of the vertex, opposite sign. Y value of the vertex is same sign. The axis of symmetry is always x equal to the x value of the vertex. This next one, +1, +5, x is 1. Okay. So we're writing an equation in vertex form, so you want to have this little formula memorized. Don't forget about the squared. The vertex is hk, the point that it passes through is x and y, so we're going to plug those values in for hk, x, and y, and actually solve for a. The a value in front tells us if it's vertically stretched or compressed. Kind of think about order of operations. We'll do the -2 plus 5 in parentheses first. We'll square, do 3 squared, which is 9. Bring the 9 in front of the a. Subtract 4 from both sides, and then divide both sides by 9. So we get our a value is -1/3. So final answer, keep x and y, and we'll go ahead and put our vertex in, and don't forget to square it. All right, so that's our final answer in vertex form. Okay, here we're doing some factoring. So in part A, there's 2 terms. If it's 2 terms, it's either difference of squares or greatest common factor. This one is not difference of squares because they're not perfect squares. So greatest common factor means that we're going to split it into the factor components. We're going to see the biggest number of things that they both have in common. In this case, they have a 3 and an x in common, so that's going to go out in front of our parentheses. On the inside, we have a 5x minus 1. So 1 is a factor of everything. Make sure that we put the 1 there to kind of hold the place. Okay, next we have a trinomial here where a is 1, meaning the number in front of the x squared is a +1. This is an easy situation to think about. It's 2 parentheses side by side. Put an x in front. X times x is x squared. We're thinking about FOIL. Then we want 2 numbers that multiply to 20 and add to 12. So it's going to be +10 and +2. Okay, next, this is a trinomial. A is not 1, there's a 5 in front, but before we think about the A times C method, it's good to check and see if that number in front is actually a common factor. In this case it is, so we're actually going to factor a 5 out, which is really like dividing everything on the inside by 5. Okay, now that we've done that, we can think about, so keep that 5 in front. We can set up our parentheses side by side. Now it is a trinomial where a is 1. Two numbers that multiply to negative 24 and add to negative 5 are negative 8 and positive 3. Okay, next one. This is a special one. The first term and the last term are perfect square numbers. So it's actually a perfect square trinomial. So we can write it as 3x squared and 2 squared at the end. So this is in the form of a squared plus 2ab plus b squared. You can memorize this. That's going to factor into the quantity a plus b squared. So it's just 3x plus 2 squared, and that's it. Next one is two terms. It's a difference of squares, so factors into x plus 5, x minus 5. Okay, the last one, we need to do the a times c method. There's a 2 in front, but 2 is not a common factor of everything. So we start by doing a times c. I'm actually going to move that over so we have a little bit more space. A times c is 2 times negative 18, which is negative 36. So we want two numbers that multiply to negative 36 and add to the b value, which is 5. So those two special numbers would be positive 9 and negative 4. So what we're going to do with them is we're going to rewrite the middle term using the two special numbers as coefficients, positive 9x minus 4x. Factor by grouping. So the greatest common factor in the first group is a single x, leaving us with 2x plus 9 in parentheses. In the second group, we can factor out a negative 2, also leaving us with 2x plus 9. So making sure that what's in parentheses is the same, the 2x plus 9. Our final factored answer, two parentheses side by side. One of them is the one that is the same, the 2x plus 9. The other one are the other factors in front, x minus 2. Okay, we've got another equation here. It's in standard form. So we'll do minus b over 2a to get the x value of the vertex. Be very careful with all the negatives. So the x value of our vertex is negative 2. And we'll plug that into the equation for x. And we want to do order of operations. So negative 2 squared is positive 4. But there's still a negative in front, so we're going to write it as negative 4. This middle part turns into positive 8 plus 5. So altogether that is equal to 9. All right, axis of symmetry, x equals the x value of the vertex. Y-intercept is the number at the end. In this case, it's 5. So let's go ahead and graph this, negative 2, 9. Y-intercept at 5. Okay, so that's the right-hand side of our parabola. Let me see if I can make that a little bit better. Parabola shape, there we go. Okay, so now we can actually use the axis of symmetry, which is that vertical line that goes through negative 2, to help us. This point is 2 spaces away from the axis of symmetry, so the same height, go 2 spaces on the other side, and that's how you're going to get your third point. Our domain is all real numbers. This time our range is y values less than or equal to 9. All right, our vertex form, x plus 2 squared plus 9, negative in front for the a value because it was negative for the a value, negative 1. X value of the vertex is the opposite sign, y value of the vertex is the same sign. Okay, this one is on the calculator portion of the test, which will be on Monday. So we've got a list of data. We want to find the quadratic regression equation. The word model is another name for that. Basically find the equation for the line of best fit that's going to go through these points. So we're going to want to go to our calculator. We're going to get to our list by pressing Stat and then press Enter for edit. And I already have the numbers in, but you can pause the video if you need and type your numbers in. So the X list and the Y list. So this time X list is the height of the ball. The Y list is the distance, Y is the height. X is the distance away from the thrower. Okay, press Stat, Calculate, go to Quadratic Regression, press Enter, and this is going to give us the equation for our line of best fit. It says to round to 3 decimal places. So I'm going to take a snapshot of this and bring it over here so that we can more easily record this. Negative 0.026. Look at the 7. It's going to push up the 5 to a 6. x squared plus 2.311x plus 25.423. Wait, that should be 0.429. Yeah, that's a mistake. I don't have the pen with me, but should be 0.429, sorry. Okay, so now to find the maximum height, we're going to type our equation into y equals. Oh, bummer. All of these numbers are going to be a little bit off because I rounded that c value wrong. So your numbers might be off from what's shown here on the video, but that's okay. We're still getting a good review of the process. So I'm going to go ahead and put the window back -10 to 10 in both directions, and then go ahead and hit graph. And we're going to need to change our window. The vertex is up there somewhere where we cannot see. So I'm going to go back to window and change the y maximum. Oh, it looks like I'm also going to change the x maximum to make it a little longer, a little off to the right. Change the y max to make it taller. So it's just a way to zoom out. So go ahead and hit graph. And here we go. Yeah, this is going to look like, I'm not sure why it's not showing up. Okay, there it is. That's going to look a little bit better. Oh, okay, make the x maximum a little bit bigger. Okay, there it is. Very nice. Okay, so we want to see that vertex. So press second trace, go down to maximum, and it's going to ask us the left bound. So you're going to move that little blinking dot to the left of the vertex, press enter. Okay, move it to the right of the vertex, press enter. All right, where it says guess, press enter again. The coordinates at the bottom of your screen are the maximum. The maximum height is going to be about 77. And I realized another mistake I made. I was saying feet, it should be inches. So pretend like it says 77 inches. Okay, how far the distance away from the thrower? So that's the x distance. And so this is about 44 inches. But again, I made a mistake when I wrote it, accidentally said feet instead. How far from the thrower was the ball when it hit the ground? So we're looking at the x-intercept. Over here, that's when the ball hits the ground. That's when the height is equal to 0. Okay, so that's going to give us the distance away from the thrower. So if we go back to second trace and choose 0, which is another name for x-intercept, so we want to do the left bound, so we'll go ahead and move that blinking dot. You can really press enter any time it's on the left. I'm going to get it a little bit closer to that x-intercept. Okay, left bound. Great, and then move it, keep moving it over for the right bound to the right of the x-intercept. Press enter. Enter one more time, and that's our x-intercept value. So it's about 99 inches away from the thrower. At some point, I know I figure out that it's feet instead of inches. I think it's right here. Okay, so a height of 50. So we're going to go back to y equals, type in y equals 50. All right, there's actually two places where the ball is a height of 50. So there and there. So it's actually the point of intersection between these two lines. So if we press second trace again, choose option 5, which is intersect, press enter, and it's going to ask us, is this the first curve you want? Press enter to say yes. Press enter. Okay, it's going to automatically jump to the second curve. Press enter. Press enter again for guess, and that's one intersection point is when it's about 76.5. I wonder if I just wrote it as 77. Okay, this is where I think I'm going to figure out that it's inches and not feet. I'm thinking, there we go. All right, it's inches. Yeah, I think when I first did this, I was thinking, wow, feet. That's quite, tall and far distance. Okay, so we're going to change it all back into inches, but then we're going to go back because there's another point. There's another intersection point. So second trace, choose option 5 for intersect. What I'm going to do this time for the first curve and second curve is just move that blinking dot so that it's closer to the other intersection point, and that's going to calculate that other one for us. I'm going to move it so it's closer. All right, but I'm still going to press enter to say, yep, that's the first curve. Press enter when it jumps to the second curve. Press enter again when it says guess. Oops, okay. About 12 inches for the other one. Okay, we're doing some more factoring here. So difference of squares, we can write this as 3x squared minus 1 squared. So we're going to factor that into 3x plus 1 over 3x minus 1. Not over, what am I saying? Times 3x minus 1. Oh, I'm tired. Okay, next one we're going to do the AC method. A times C is 6 times negative 2. So two numbers that multiply to negative 12 and add to 1. So that'll be 4 and negative 3. So we're going to split the middle term into 4x minus 3x. And then we're going to factor the first group. Greatest common factor is 2x. We're left with 3x plus 2. We can take out a negative 1 from the second group, also leaving us with 3x plus 2. The 3x plus 2 is the same, so that's going to go in one of our factors for the final answer. And then 2x minus 1, that's going to go in the other factor. Okay, anytime you have a negative in front of your x squared, factor the negative 1 out, which is just really going to change the sign of everything that's on the inside. Now in this problem, two numbers that multiply to negative 8 and add to negative 7 be minus 8 and plus 1. All right, the last one here, we have a perfect square trinomial. So we can write the first term and the last term as perfect squares. So this is in the form a squared minus 2ab plus b squared. That factors into a minus b squared. So this is just 5x minus 4 squared. Okay, solve by factoring. If not, solve using a calculator graph. Round to 3 decimal places. Okay, so first one, we are able to factor, so two numbers that multiply to 25 and add to 10 are 5 and 5. So because it's the same factor, when we set the factor equal to 0 and solve for x, we just need to do one of them. Subtract 5 from both sides, we get one solution, which is negative 5. All right, next one, we want to rewrite it so that it's equal to 0 first. Two numbers that multiply to 10 and add to negative 7 are minus 5 and minus 2. Set each factor equal to 0. Solve each equation separately to get two solutions. Add 5 to both sides, add 2 to both sides, so we get 5 and 2. Okay, let's see if we can factor this one. With the AC method, we would have to find two numbers that multiply to a times c, which is negative 6, at the same time that add to 8. This one is not possible to factor because if we think about what multiplies to negative 6, we have 1 and 6, 2 and 3, obviously one's positive, one's negative. None of those combinations add to 8, so this one is not possible to factor. So instead, we're going to type it into our calculator, and we're going to look for the x-intercept on our calculator. So just go back to your y equals. We'll clear all of this out, and we'll type our equation in. Okay, we'll double check our window, change it back to that standard window setting of negative 10 to 10 in both directions. And let's go ahead and hit graph, and we are looking for the x-intercepts because those are the solutions when it's set equal to 0. We have two x-intercepts that are showing up here. Press second trace 0. 0 is another name for x-intercept. Okay, so left bound, right bound, press enter. One of our x-intercepts is about 0.23, so that's one of our solutions. All right, second trace 0. All right, we'll move this one all the way over to the other side. Get on the left of it, left bound, press enter. Right bound, press enter. Press enter one more time. And this x value, this is a little bit slow. The other x value negative 2.9, so that's the other solution. Okay, the last one is possible to factor. We can take out a greatest common factor of 8x, leaving us with 2x minus 1. Once it's factored, just like the others, we'll set each factor equal to 0 and solve for x. The first one, divide both sides by 8. 0 divided by 8 is 0. Add 1 to both sides. Divide both sides by 2 to get the other solution of 1/2. Okay, find an equation in standard form of a parabola containing these points. So this is where we are going to write 3 equations. Our first equation is, so they're all based on ax squared plus bx plus c, which is standard form. All right, so first equation is 410. We're going to plug in x equals 4 and y equals 10 into that standard format, leaving a, b, and c. So we'll simplify this down. That is our first equation. Second equation is using information from the second point, 0, negative 18. So plug in negative 18 for y, plug in 0 for x, and this one just ends up being 0a plus 0b plus c. If you leave the zeros in there, it's helpful for when we turn it into a matrix. All right, we'll do the same thing for the third point. Negative 2 squared is positive 4. Okay, so now I'm going to go back and rewrite these 3 equations together in a system, but I'm going to write all the variables on the left side, and then just write the number part on the other side. So that's our first equation. Let's rewrite our second equation. I hope this video is helpful to you guys. I so wish my teachers were able to make videos when I was in school. I think this is an awesome resource. All right, so now we're going to turn this into a matrix. So we're going to take our coefficients of the a, b, and c, and the number on the other side for the 3 rows of our matrix. All right, we're going to go ahead and go to our calculator. So press second x to the negative 1, which is going to get you into the matrix menu. Arrow over to edit. Press enter. I already have the numbers typed in, but you can pause the video and type them in yours if you need to. All right, then we're going to quit out of this by pressing second mode. All right, go back in by pressing second x to the negative 1. Go to math. And we're going to go down to RREF. Press enter. Go back into the matrix menu one more time. Press enter to select matrix A. All right, press enter. So here's our solution. A is 1, B is 3, and C is negative 18. So our final answer in standard form, y equals 1x squared, or just x squared, plus 3x minus 18. Okay, last question. This one is in vertex form. So to get our vertex, it's negative 5, positive 3. Axis of symmetry, same as the x value of the vertex. Go ahead and plot our vertex. A is 1, so it's that general pattern of over 1, up 1, over 2, up 4. You can memorize that pattern of points. It always works when A is 1. If A is not 1, then it's going to be a different pattern of points, but that's going to be an easy way to think about this graph. Our domain is all real numbers. Our range is y values greater than or equal to 3, or you can write the interval notation, bracket 3, comma,